All right, everyone, welcome to yet another Kubernetes SIG, Special Interest Group, Cassandra Kubernetes SIG. So I think the point of this meeting today is actually doing some engineering work. And a huge thank you to John Sanda, who's here. He jumped in and did kind of the hard work of going through a lot of different operators and trying to, if you recall from our last meeting, we're talking about, okay, let's start with a CRD. Let's work through the parameters and kind of go top down. This is how Kubernetes projects are done, through the API, and the API is expressed in the CRD. And so John did that work, and we have a consolidated document. What I thought would be really useful is John can walk through the document, and John, I don't know if you want to do a screen share. That might be the easiest thing. John could walk through the document. We could talk about each section. I saw we already had some great comments in there. Cyril, Alex, Stefan, who I wish was here, but he's not, had some great comments. But I think this will be a good time. The goal is to start doing some level of merging here, or trying to consolidate if we can. Hopefully we can get a large portion of it. Like, yeah, this is all pretty common, and we should do that. And then we can just get down to the debating, like the finer points, and if we can. The next step will be, since John is doing a lot of the, like, has the time to do the work, we could take that input and actually turn it into something that can go on something like GitHub. You know, take it from, Google Doc coding to actual code, and see if we can keep the project going. So with that, John, why don't you go ahead and take it away?
Okay. So thanks everyone for reviewing and commenting on the doc. I should have put in the doc for some background information. The objective was to look for least common denominator and use that as a starting point for comparison. For example, I think all of the CRDs for each of the operators provide ways for configuring resources, CPU and memory, for example. And so, or configuring Cassander itself, albeit differently. So there are things that features that each operator has that others don't. For example, Insta-cluster operator and CAS in progress for backup restore, while CAS operator doesn't have that. I intentionally left that out because I wanted to just look at things that are in common but maybe implemented differently. And this wound up taking more time than I thought, so there are things that I definitely missed, so I appreciate the comments, and please feel free to jump in and interrupt. Or I want to be the tour guide and let folks who are more familiar with these things drive the conversation. So I grouped it into the categories of the cluster topology, resource configuration. Initially, I called it the Cassandra pod configuration, but it really is more about just some of the underlying resources. And then the Cassandra configuration of Cassandra itself, storage, and then sidecars. So I'm going to skip over this probably should have been left out, the minimal example. The Insta-cluster operator was, and for any folks here from Sky UK, I intended to do cover all four of the major mature operators. Again, it was just, I ran out of bandwidth. So I'm going to skip over the minimal example. That was just because I was least familiar with Insta-cluster's operator and just kind of poking around the code and getting familiar with things. That was scratch work. So in the cluster topology, the first thing that I wanted to note was, of all the three operators that I was reviewing, there seems to be pretty similar with the being able to define racks and pinning racks to availability failure zones. There's, albeit, maybe some differences, but that seems to be pretty similar, as well as just defining the number of nodes in the cluster. I highlighted tolerations for insta-cluster operator because that was one thing that I think was unique to insta-clusters operator. Although I think CASCOP has you can declare tolerations, but in a different place. Oh yeah, there it is right there below. So yeah, there's CASCOP. So if I go down to CASCOP, we see very, again, similar with, let me go down here. Declaring the racks. And I highlighted with CAS, and then I'll jump down for a moment here. With CAS operator, we see the racks as well. One of the things that is different, and I'd love for folks, somebody from Instacluster and the DataStacks to chime in. So we see or any of the teams, so with the CASCOP, you can declare multiple data centers in the spec. You see the DC, and then racks within the data center. And both with CAS operator, let me scroll down to CAS operator, your top level object is the data center. And I left out the full spec just to kind of try to cut down on the boilerplate. And similarly with Instacluster operator, it's the top level type is the data center. It seems like it's a first spot I'd love for anybody from each of the teams, if time permitting, to share a little bit of thoughts on the decisions around there, since that's one of the first distinguishing points between them.
I think it's interesting. So with CASCOP, is it a cluster level? And then you describe the topology underneath. So DCs and racks and what?
Yeah, it is. It's on the location level. So a cluster is located in a Kubernetes. A Cassandra cluster is located in a Kubernetes cluster, and in that cluster you can create as many data centers that you want, and we use label to just specify where we want those nodes to be hosted.
But
okay.
we have the case
so if we have of a data center. I'm sorry, go ahead, Frank.
No, I was just saying that we have the need. We have different clusters on the same data center that are handled by the same CASCOP instance. That's why we do that. That's right.
Would we want to look at something similar to how Kubernetes does pods and pod spec templates? So we could have a cluster level which has a data center or data center spec templates that are used to populate out values in the varying data centers. And then the operator could handle actually creating those resources. It seems it's kind of like what you guys are doing here with your topology key.
Yeah, we saw that SDK, not Cassandra, but the distributed storage thing is kind of similar to this. And I think, John, if you scroll up a little bit, we've talked a lot about we just have size defined in one place, and whether we want to move to you can define racks with different sizes, which we think is probably good, but probably someone has some use case. Anyway, we're trying to spread best practices. I think we decided probably nodes per rack is better than what we have for a couple of reasons. So anyway, I'm not sure if that's what you wanted to talk about here, but yeah, just sort of how these things are nested and structured. Like we're happy enough, but yeah, I have questions some of the choices we've made too.
I don't know
Yeah,
if
sorry,
it's
your connection is way bad.
I really have struggled to understand what you're saying. I don't know if it's only me, but
No. It's I think it's
No,
everybody.
it's
There's a
not
lot of
just you.
static.
So maybe John, you can just rephrase what Jim said, because I maybe got 15% of it.
Did anyone get what John or Jim said? All right, because I was struggling too. Okay, Jim,
Okay.
your
I'm the only
microphone
one daring.
It's
failed
not
you.
only non-native speaker.
It's better. Some people told me it's better. Some people told me my headset was broken yesterday.
Now I can't hear a thing anymore.
Yeah, now you're very, very, very quiet, and it seems like you're saying
Sorry.
something important.
Just try the test thing because it's.
And don't worry, I'm recording this, so we can all watch it later too.
Yeah, it's going to be on the web.
Yeah, there's something going on with your audio, Jim. It sounds like you're speaking from the moon, and yeah.
I'll be right back.
Yeah, I was gonna say. Did you
Yeah.
try rebooting?
Well, Jim reconnect here.
John, did
I
you
will
get what
say
he said?
the label structure that you have here is pretty awesome. I've been talking with users and assuming that the nodes are labeled with that specific failure domain label. It's changing too between Kubernetes versions, and I expect it to change across the clouds as time goes on. Supporting arbitrary key values, label key and value pairs is pretty interesting, and it looks like you support rules. So if I were to say like maybe disk equals SSD, that gets passed through to the node selector, right, Frank?
Yeah, on our side, we had to do that because we have some quite silly way of labeling our nodes with rows and rows, how you say, and it was so difficult to, because we had Jean Hamel that actually wanted the node to be specifically on different nodes all over the place, so we had to make very open system for it to be able to match whatever was given to us by the Kubernetes team. So the Kubernetes team agreed to label all the nodes with the geographical assets, and then we could actually say we want this on this availability zone that we simulate with being a row of machines. That's why we did that.
Gotcha. This is a really mature methodology there. It's very flexible. I'd love to see that in our one CRD to rule them all, or multiple CRDs, whatever it ends up being.
Yeah, I think having. Can you hear? What first? Can you hear me better now?
Not enough yet.
You need to turn your volume up there, bud.
Turn the volume on. Before you had to
Exactly.
turn it off. It was too much power. Now it's too little. Try it.
It's like a chipmunk for now.
Poor Jim. Shows up to a meeting where he wants to say something, and it's like, no.
You need to test your audio before you join.
So just real quick while we're waiting for Jim, should we capture some of these things in a note inside of here? Just thinking out loud. There's some good discussion going on,
I'm gonna
but
put some comments in here.
yeah. Put a comment in there, like, yes, what you said, Chris. We don't want it to get lost. I mean, it's not lost because I'm recording it. What if I have a hard disk failure? We're all Cassander people. We know that happens a lot. But I have an RF of 1 right now, so. All right, why don't we move on and we'll let Jim catch up with this.
Okay, yeah, and when Jim gets back, we'll circle back. Definitely want to catch what he said. Let me. Okay, so the other reason when I came across I started off looking at InstaCluster first, working through it, and then Cascop, then Cas operator, and I saw the stuff about tolerations, and I was vaguely familiar with taints and tolerations, but I needed to do some reading, and it seems that I'm still a little confused. Don't have a lot of experience using it directly, but to me, it seems on the one hand, it seems like there's just some redundancy with affinity rules. But based on some reading I did, it looked like it's complementary. So, which is part of the reason I've highlighted. So, for example, it's the one example I saw, which is I think a really good illustration. You have a node that has memory pressure, and you add a taint to the node that it's low on memory, and only pods that tolerate that taint will be able to be scheduled to run. All of the nodes would potentially be evicted from that node and scheduled elsewhere. So I like seeing the ability to specify the tolerations at some level, knowing that it's a. Let's see. Both. Oh, the other thing. I didn't notice or may have missed it with the InstaCluster operator, but both Cascop and Cas operator have basically the ability to, where you say, whether or not you want to allow Cassandra pods to be co-located on the same node. And I think that's great because maybe for development testing, you want that. For production use, you maybe don't want that. And so just to have that ability or you're just more resource constrained and you want more density. Let me see that. Okay, so feel free to stop me. And just due to time, I'll try to focus on the highlight.
If you're going from section to section, let's do a quick check-in with Jim.
Okay. And you hear me now?
Oh,
excellent.
It's perfect.
Yes.
So one laptop's internal mic is busted. My headphone mic busted. All right, second laptop, normal mic busted. Okay. Okay. So what I was saying before was, the very first thing I was saying was, we've been thinking that nodes per rack is a better system than what we have, where we just specify like a size and then do a division and try to keep everything even. It's very confusing if you want to try to add a rack, like what are you doing? So we added all this logic in the webhook to block that. So anyway, I like the Cascop way. But yeah, I think we decided we did not want to just push down like a size to each rack, because that encourages bad practices of really out of balance things. Even if like someone is like, oh, but I needed that this one time. It's like, no, but you should probably have better practices when you start from scratch in Kubernetes, right? So that was one thing. The taints and tolerations and maybe like a node selector or something, it felt like a lot to us, and we avoided supporting it at very first. And I guess I'm glad we did, but you eventually do need to support all of it to support the more heterogeneous workloads people will put in their Kubernetes clusters, where it's like, oh, I have like this instance is dedicated to GPU stuff, and I don't want Cassandra on there. So we added node selector when someone asked us on GitHub, and that was fine. But I even said, like, are you sure this is enough for you? Like, you might need to repel our pods from other things. And he was like, no, like we use node selector everywhere, so it's enough. But giving people that freedom, it's very hard. And my last thing that stupid audio problems were ruining was like, as far as like the labels and the he said rooms and rows. And I think getting that feedback is really important, because like we're 100% in the cloud, so knowing how people expert in managing their own data center doing it is, we want to support that. I mean, as long as there's some good organization, like we should make sure we have support for that.
Are you really 100% in the cloud? You're 100% in Kubernetes. That may be not really in the cloud. It may be in your premises where you don't have an infinity of machines, and that's our problem actually. That's why we did that, because we had constraints on that were given by Cassandra experts that didn't want
Right.
nodes to be on the same, and they really want to say, they said that's the condition for Cassandra to go into Kubernetes, else it's not going to work. If you say let's be clear, let's drive the thing, it may not work. That's actually why we did that. But I mean, it's completely, you don't have to put it. I mean,
Right, exactly. Yeah. But just
that's
knowing.
your idea. I mean, if you don't want, you don't talk to people. But if they ask for, how can I specify more? You can say, oh, you can add some labeling if you want. That's the whole idea.
Yeah, we support the failure domain label sort of out of the box with a simple thing. It's like, oh, label that, just take this rack and label it with this availability zone, and it just works. Kind of look, it doesn't, I don't know, if you're very new to this stuff, it might look magical, but it's all just counting on existing plumbing.
It's a matter of safe defaults, you know, and I think of like Cassandra already has a lot of that, but that's in the Cassandra world. But if you're not specifying, you know, if you're not being overly prescriptive in your YAML file, will you get a safe or a sane, I hate to use the word sane default, it's safe defaults, because we're talking about infrastructure.
I found this hard to make examples where it's like not knowing what region or cloud anyone's in. Like, how do you, I can't really put up with examples that show using these features. You can, but then someone will copy paste it and be like, it doesn't work. And they're really testing nothing except, you know, that everything else is working as it's supposed to. And you have to kind of research these values before you slap them in.
One question to you, Jim. Sorry, Frank.
No,
one question to you. You said you didn't do the same thing regarding the parameters per rack, I think, or per DC, I think. I'm not sure, per data center. Maybe you have only the notion of, I mean, the cluster is a data center for you. I don't remember. I think that's what John said before. But you said you don't want to have specific parameters on the data center or on the rack? Okay. Okay.
Yeah, and it's not that I don't, we'll have them if we need them, but just letting you have like one rack with 2 nodes, one rack with 3 nodes, one rack with 5 nodes, like we're like, what's the purpose of letting all these kind of odd snowflake configurations be legal? It's like, in that case, it's like you can put a 10 and then have 3 racks, and then the first one is going to get a 4th node. And we're very deterministic about where we put the nodes in the racks, but even then we're thinking like, maybe that wasn't even, like, why do you need that freedom? Maybe you should just say rack nodes per rack 3, and then put 3 racks, and then, you know, you'll get 9, and you just can't ask for 10.
Yeah, it's just a matter, I think, of not having the same nodes, the same number of nodes per data center. So we can have a data center where we just run Hadoop jobs, where we don't have the same replication factor. So we have less number of nodes. So we don't really need that notion of, you know, that high number of rack, and maybe also that number of nodes per rack. So just a way also to, you know, not waste space by having the same rack and the same number everywhere.
Yeah, we support multi-DC as long as it's in one Kubernetes cluster. And ideally one namespace is how it works right now, which lets you get those, you can get the workload separation out like that, but we don't have anyone, like Astra is not testing that very hard right now, so.
No, but do you have a Kubernetes cluster that spans across data centers? I haven't seen that yet.
That would be nice,
multiple Kubernetes clusters, or?
No, one Kubernetes cluster that spans multiple data centers.
Yes.
I mean, we have one we have 3 data centers in different places in France, and we have one cluster in each because it just doesn't work. I mean, there is latency that just doesn't work across clusters. I mean,
I understand what you're saying. The idea of the Kubernetes data center, or like your physical data center. So the cloud providers tell you like US East 1A is a different data center than 1B is a different data center than 1C.
They're availability zones. That's why we say here you can put them in AZ. but in well, I mean,
Yeah.
more into an on-premise kind of guide that we try to make it feasible to work on-premise and on the cloud. That's the more difficult on-premise, I suppose.
This
Yeah,
is the
I agree. It's more difficult.
fundamental
Sure.
difficulty with Kubernetes right now as it sits, when we're talking about Kubernetes and Cassandra working together, that's a huge mismatch. Kubernetes does not do multi-data center. And even if you were to VPN or bridge it or anything like that, you nailed it. The latency is too hard, and it doesn't have the ability to do things like partition events or anything like that. So, but then Cassandra is just fine with that. So I don't think we're going to solve it with this CRD. Multi-data center, multi-rack, I think when we talk about it in these terms, assumes single IP plane that doesn't have latency, maybe inside of a physical data center.
Hey guys, this is Amir. At the risk of confusing matters even further, I just kind of want to point out that I think all this discussion sort of presupposes that Kubernetes itself is scheduling the pods. There is a notion of outsourcing that to something like a storage orchestrator like Stork, which is actually the route that we've taken at DreamWorks, which is to say, maybe we'll get to it when we get down to the storage section, but we let our storage, where our actual persistent volumes live, we let that basically dictate where the pods get scheduled. Put another way, we take the compute to the storage.
I'm seeing a lot of people going, Omer, good job.
I'm not sure.
That's the key. I mean, storage is the key. I mean, for us, we don't have yet a very competitive network storage that is available and fast, because if it's available but not fast, it doesn't work. But so we use local storage with so we have the problem of locating pods in nodes. I mean, if we have EBS-like storage on premise, then well, much less problem. You can move things around much more easily. So I agree that but should we start from the hypothesis that people have a network storage that is fast enough?
I wouldn't even call it network storage. So in our case, so we use things like Portworx or even Trident, which effectively makes these volumes appear as local storage to our containers. But again, so I mean, as far as the CRD discussion goes, I don't necessarily think it's a problem having specifying a topology here. If there's some way when you implement your controller to actually push this down through to your storage class, or when you're actually creating your storage and then letting that drive the pod scheduling, that that could be an option for people. And again, the risk is trying to solve every problem I know that we can. It's like there's going to be different people running in different with different architectures. And so I was just trying to bring up the point that this discussion that we're having right here is somewhat limiting, because it might not allow for a scenario like I discussed where you are using like Stork or some other storage orchestration.
Yeah. So that brings up so if you're using a storage class for local storage, and then you declare a PVC for that storage, even with the defaults, and I'm definitely not very familiar with the algorithm of the Kubernetes scheduler, but wouldn't that necessarily then the scheduler limit the selection of potential nodes for a pod to those nodes with the available storage?
It probably depends on how things are labeled. So it depends if you're creating the storage first and then attaching pods to it, or if you're letting basically you're scheduling a pod and then creating local storage where that exists. I guess it really kind of has to do with how the selection criteria for the pods, what is considered in the list of you know, available match selection, I guess, for the Kubernetes scheduler, right? So I think it's going to ultimately come down to how those things are labeled.
Yeah, so I guess maybe a question of in that the selection process in terms of trying to schedule what criteria is evaluated first in that process.
Yeah.
From my experience, doesn't sound that different to honestly how ABS ends up working with Kubernetes or GCP's version, the persistent disks. So if I say like I need a pod in this availability zone, and like for whatever reason I can't get a volume in that availability zone also, that pod is left pending. And then let's say I fix something like what's on screen right now, and the operator targets gets rid of that pod or rewrites that stateful set to target another zone, then it can get volumes there. It still is checking like if my CPU and RAM requests fit on the node that's trying to get the pod on that has the storage. Then if I like take that pod away, because like we have this idea of like stopping to do like a cold, like, you know, take all the compute away, the storage is left in place, and like you can start it up again later. All the pods have an identity, so they go back to the if the volume for them is only on exactly one worker node, like it'll have to target that one. And if some other jobs have come in eating up the CPU, RAM, whatever, and they can't, then that pod will get left pending again. So I think it's important to make sure these scenarios work with whatever we're producing and putting out there for the Cassandra community. Like it should work well on cloud and it should work well on prem. And I mean, you can use a bad storage provider though that doesn't kind of fulfill its other half of the expectations, and then yeah, like the PVCs need to have a node affinity basically if you're using local storage, right? So if you're using a local storage provider that doesn't do that, like it's not really fulfilling its job. I've only really done experiments about this, so like you can tell me if something I'm saying is wrong, but like I did try to work far enough through this so that we could try to run Astro with local storage. We're not right now, but I did do enough work to see that it seemed quite possible to do on Amazon and GCP.
I'm not sure. Sorry,
go ahead.
Umer, I'm not sure how it's an edge case what you're talking about, except if you need to use a storage class, a different storage class per zone or something like that. Because today we use the same storage class for all the nodes. So as long as in each region the storage class provides the right storage that you expect, it will work. And it's on Kubernetes to just get it and the drivers that you use and everything. But other than that, I can see how it's a problem with the definition that we have, except if you need to use different storage class per rack, for example.
Yeah, well, so I can give you a quick example of like, and just to be clear, so the Astra folks, like we've been working with NetApp on some of this stuff too, and I know this is, if it's not already in their product, it should be soon. But so for example, we use Portworx for our to create our persistent volumes, right? And a Portworx volume has the notion of replication itself. And so what we choose to do is in the storage definition itself is where we define our affinities and anti-affinities, so that we can say for a given Portworx volume, for example, ensure that both of those replicas live in the same rack, so that we can ensure ensure there's no latency between the replication because it's synchronous replication. But at the same time, all of the volumes for a given Cassandra cluster, let's say it's a 3-node Cassandra cluster, we want each of the volumes to have anti-affinity and to all live in separate availability zones, right? And so we actually specify that, again, not at the pod level, we specify that for the storage volumes themselves. And then Portworx will actually go and create those volumes as need be. And then that informs Kubernetes to go and schedule the pods local to wherever those volumes and replicas live.
So are you saying that you need some storage, some ways to configure the storage class that we use at the rack level?
Potentially. What I'm saying is that this CRD, whatever controller that we'll develop to implement, the underlying actual affinity, may need to take that into consideration, and we may want to push some of that logic down to your storage level instead of just having your pod scheduling, assuming that that's going to handle it, right?
Yeah, I mean, that's not something we do currently, but that can be added, supposedly. I guess if you have some constraints that you want to put to the PVC creation, I suppose it should be feasible. But that's what we say. We need to be as flexible as possible at every level, including the storage, possibly.
Yeah, that's why we try to add as much configuration as possible to the CRD, so users can add sidecars that they want to use on each node. They want to use, I don't remember what we've added, but we did the same for tolerations. So yeah, we try to add as much parameters as possible to the CRD without making those required. So they can be added if you need them. You can skip them if you don't.
Sounds like a good request for Cascop for me.
Cool. And I guess just the last point I'll make about that is the Stork seems to be sort of the favored storage orchestrator. Again, used by NetApp, used by Portworx and others. So that'd probably be, instead of trying to target everything, if things can work with Stork, then I think it kind of solves 80% of the use case.
Yeah, thanks, John, because I can't understand everything. So that's good to have the written version.
Great conversation, by the way. This is exactly what I hoped would happen, as we get this back and forth. Omer, by the way, Omer and I had a great conversation last week. Omer's been working with Kubernetes and Cassandra for a long time at DreamWorks. So as I see it, is like a great example of someone also running this in production and having to deal with it, with a different point of view. And that's exactly what we need to see here. So thanks for speaking up and showing up in there.
You bet.
Okay.
I'll jump down to resource configuration. Actually, yeah, I'll just go in order of resource configuration. So there's more similar, I think a lot of similarities here. Stefan, if you're on, I saw there's the optimized kernel params, and if I remember, I thought it was was interesting and unique to InstaCluster, and I saw some comments saying about for locking memory with the Cassander container, which is interesting. And then I highlighted there's the ability here to add labels and annotations for each of some of the underlying pieces, which I think is great because I think you need that. However, my personal take is that while you need the flexibility, I also think it would concern me that maybe you expose too much implementation detail. So want the flexibility at a higher abstraction level. For example, let's say that let's say that one of these services goes away, and just that's one thing that stood out there. Similarly here, you see that options for Cascop for adding the annotations, different flavor. Something unique with Cascop. There's a debug flag, which is interesting for basically running so that Cassandra doesn't start allowing you to attach shell to poke around, which is certainly could be very useful. And made me think. I was reading about. I think it's somewhat new. What is it? What's it called? Exactly for. I have to look it up. There's containers designed for. I think it's new in 1.16 or alpha in 1.16 for exactly this kind of purpose.
Ephemeral container.
Yeah, ephemeral. Thank you, Cyril. Yeah, ephemeral container. Have you played around at all with ephemeral containers?
Yeah, we played a little bit in order to have ways to administer the cluster if something goes wrong, for example. So yeah, we started to look into it.
That was done long before Ephemeral was out, because Ephemeral just came out recently, so we had to put that in place quite some time.
Okay, so I'm going through that section quickly because I want to get to the more interesting section, Cassander configuration. And I think this is a really interesting area because it's a very non-trivial area and very interesting solutions across the operators with different approaches with each operator. With InstaCluster, there's files getting, let's see. See an example here where for some of the Cassandra properties exposed, like the auth, and then we can define a config map volume source and paths with sections of the configuration, files with different pieces where they're going to get merged together. And I'm not doing justice explaining this, but so I'll leave it at that. And then with Cascop, similarly, and using a config map with scripts to do some customization. And Cas operator, you see the configuration exposed. You can, I think pretty much all of the configuration settings, and there's a helper config image that I think handles it. But I'll let folks who know more about these jump in and talk more about it.
Let me tell you one thing. So we thought about doing something like that, but we were annoyed by the fact that some parameters could be removed in V4 or being added. So we didn't want to handle the different versions and I mean, what you already handle in the Cassandra Docker image that we use. So we just looked for a way to just, give the configuration that we need to override, and that's it. If they want to add comments, if they want to add whatever they want to add there, they handle the whole configuration directly. Yeah, we just chose the easiest way for us.
Yeah, we're probably somehow on polar opposites here, but what exactly your concern is what we tackled. So I'll say that so we support. So we took part of a product like the cluster lifecycle manager that DataStax sold and extracted out the configuration management part into like just a CLI, and that's what's running here. That understands that YAML, like that was its native language already, so it was like easy to just embed here. So Cassandra YAML, put num tokens here, an authenticator. So it's sort of, we're being recorded. I'm not going to say what I was thinking, but it is a rather heavyweight solution. But yeah, it'll be easy to support, config changes between 3.11 and 4.0. It looks easy to support, and that just turns into another kind of big project to maintain. But it's open sourced as well, so we put it out there. I've actually had to go and change some stuff in there recently, and it's not we should put some more TLC into it, but especially if like, yeah, the gap between 3.11 and 4.0 is big, I think that would be a good point for us to decide like how to go forward with it. That being said, yeah, like we just mostly wanted to assert some pretty good defaults so that the good defaults are not a lot encoded in what we're calling that Cass config builder. And in my examples, like I think the authentication being on by default, we're going to build into something that the operator asserts as like a default thing. Like, you know, you can probably fill in those lines to disable it, but it's probably coming in the next release. Promise some better defaults. And so, yeah, it's interesting. I don't know. Like, I think there's merits to both approaches. Like, we have probably a little too heavyweight one, but it was already complete work, so it was easy enough to scoop it in. The like run a script to change your config, and it's a lot of seds. Like I think now that I'm when I started, I started with Go before I started working on the operator, but now that I'm even more farther along with Go, it's like there's some pretty good YAML tooling, and I might say like the approach you guys used is pretty great, but maybe I just make it maybe embrace the YAML data structure when you can, you know, something like that. It's easier for people to, because there's a pretty good YAML patch spec that I've used for some chores, and it'll read a little easier. But yeah, I don't know. This part, like John said, is so interesting and complicated. It's like some of the stuff I noticed in the previous part you skipped over is like, oh, that like flipping like kernel parameters, and it talks about JVM stuff. Like that kind of boils down to like, if you scroll down, John, like you can put any like, yeah, like the -d parameters. Like this is totally freeform. If you do put something illegal in there and the init container rejects it, the messaging could be improved, but you don't end up in a bad state. You're either definitely broken or you're good to go. So like all of this is pretty, because the data structure is pretty checked. So we parse all this YAML. It needs to make sense. You can put arbitrary JVM parameters. Obviously, if you put like -xx, my random thing, I think Java won't start. So, you know, pretty good user safety, I think, from what we have. But yeah, I don't want to think about how many hours of engineer work we inherited. We just kind of got for free. So
I'll just make one point. I think the cast operator technique, I guess, it just seems kind of self-documenting. So as an end user coming along, looking at just these key value pairs that match up with Cassander YAML or JVM options, it might be obvious to a Cassander operator to know, you know, oh, this, like I said, it's just self-documenting.
yeah.
When I was going through this yesterday with Patrick, I mentioned that with Cas operator, the fact that it just maps naturally to the different config files is good. And I spend time, probably too much time, trying to explain to people, convince people that it's a good idea to run Cassander and Kubernetes. And so if they make that leap and see that, well, okay, I need to change some settings and I've got to do a bunch of extra work that I wouldn't have to do outside of Kubernetes, that's just going to be one more strike against the whole effort. So I think even if there's a solution, so whether the solution is what Jim is describing, under the hood, or if it's using sed and scripts under the hood, that's one thing. As long as what the user sees is relatively straightforward and easy, is a big win in my book.
Yeah, developer experience is important. I think one of the things to keep in mind here is not all the configuration files today are YAML. And so we do have to keep that in mind if we are doing any sort of looking for these values.
Yeah, that occurred to me earlier. I mean, it's kind of unfortunate, yeah, that some of this is like fussed with environment variables, fussed with. It all kind of falls into three piles, though. I think it all looks like a JVM parameter, or it's YAML, or it's like looks like an environment variable. I forget something. Maybe forgot something.
There's XML for logback.
Oh yeah, we haven't messed with that.
What changes in Cassandra could make this easier in the long run?
I've complained to Jake a lot about this. Yeah, I've complained to Jake a lot about the scripts rat's nest, and it's just painful to trace through.
I'll take that one on. What could change in Cassandra is to make everything configurable with environment variables.
Hey, this is Dinesh. I also had a follow-up question similar to this one. Is one of the common issues I think Kubernetes and Cassandra face is Kubernetes inherently does not give you a stable IP address, whereas Cassandra relies on the IP address heavily to for some internal data structures. So just want to know, like, what do you all think about this particular topic, and if there are some areas of improvement in Cassandra that we can address for, specifically the node's identity, because I've seen a few emails fly by, a couple Jiras fly by about this particular topic. So is there some area of the document which captures the improvements we could make in Cassandra that would help ease the integration with Kubernetes? Obviously, it wouldn't help with the older versions of Cassandra, but at least going forward, we can definitely do something.
No, it's not captured in the document, but that's a great point. Something that has come up.
So I opened a ticket within Jira for this. It's 15.823. There was a little bit of pushback there, and the suggestion that we make that a CEP. But yeah, the concept of keeping track of nodes via an identity instead of an address, or specifically an IP address, when those are very fluid in environments like Kubernetes, is important. So that is one of the things that I would not be surprised to see a CEP about this in the near term. Yeah,
I don't necessarily think we need a CEP. I mean, that's like the implementation detail. But if there is a thought on going forward, what do you think we can do within Cassandra, even if it is in the context of this particular ticket, that we can discuss and say, hey, given going forward, the identity of the node is something that's going to be has to be decoupled from the IP address or something else, right? How do we decouple this? If you've concretely run into issues, I think enumerating those issues and the current solutions that you're leveraging would be a good input into that ticket as well.
I just want to do a quick time check. We're 2 minutes to the top of the hour, because I've scheduled these for an hour, just so everyone has everyone has the time. So I was thinking that probably this would be more than one meeting, but if we need to go over just maybe a few more minutes, I just want to make sure that everyone's time is respected. I know it's late in Europe right now. What I could offer is I could schedule another meeting next week, basically the same time. So we can maybe, John, take the input that's here now, roll that up as much as possible, and then continue this and continue the conversation with what's rolled up. That's my bid right now, by the way.
Yeah, that sounds good.
I think it's good to it's quite productive, but I don't know where we're going actually. That's my only. Oh, okay. We'll agree on the CRD. Okay, that's fine. If we can. We wanted to say that we have some additional features in the Cassandra configuration part. We have a bootstrap image that allows the people to, I mean, our ops had loads of requests. So we had to make it as flexible as possible for them to add anything they wanted at boot time. So they can add we have a system that copies files from the bootstrap image to the official image, because we wanted to rely on the official Cassandra image. I mean, we know that official is not really official, but because we don't know who maintains it. But anyway, so we wanted to take the image and give the opportunity to the user to add whatever he wants in there. So basically, he can add the Instacluster Prometheus exporter in there, whatever jar he wants, and he can change the start file, start command that is run. So there's lots of flexibility at the configuration. Cassandra configuration is quite complex on Cascop side, so that doesn't show there, but that's I don't know if it's there to be mentioned.
I had one question about that because I'd seen that in your repo before. Is that about just like every pod runs that, or is it about when the node is bootstrapped, like Cassandra bootstrap, or?
It's an init container that starts every time, and it's in charge of preparing everything that is needed by the image. For example, the default bootstrap that we have prepares the configuration for the Docker Cassandra image that we find in the repo. But at Orange, for example, they use a specific Cassandra image that they have because they want the Oracle Java JVM to run there. And they want to specify some parameters there that are not maybe in the Cassandra config for some reason, anything. So they can do it there. And they can do any action before starting the actual container, sending a notification, whatever. So using that way, they can do almost everything that they want.
I had some. I must have lost it in here during the editing, because I know I actually had an example with the bootstrap image. And the other night, I actually pinged Cyril to ask with a question, trying to get some clarification about it. And that brings up a question I had when I was talking with Patrick yesterday. All three operators in the CRDs in one or more places allow you to specify not just the image version, but the image itself, whether it's for a sidecar, an init container, or Cassandra itself. Is it as simple as just I mean, this is a general question. As simple, you can bring your own image you can expect things to work. That came up. I started thinking about that as I was going through this. If I swap out, whether it's the Cassandra image itself, or any of the places where you can substitute your own image. I know in one case when I was looking at, like I think with the Bootstrap with Cascop, there's really good documentation that says, what your Bootstrap image needs to do to be compatible for things to work. But that's I think a good question of what assumptions need to be in place, or if you're swapping out different images for different things.
I can give you one last example, and that's going to go back to the question that you asked about what could we do to make Cassandra better when we use it for Kubernetes. For example, we had to stop using the node tool tool, because we were using it to test if the cluster, or the node was okay, but we were just stacking up node tool calls because it was taking so much time. So we had to replace it by simple curl scripts that call the JMX, the local Jolokia agent that we have, to just check if the node is alive. So this is, for example, what we have in the default Bootstrap image. And if users change it, then they're going to have to provide scripts to do exactly the same. Maybe they can just replace scripts with calls to Node tool, but they're going to go back to the issues that we had.
Well, the main idea is to provide something that works out of the box. I mean, if you take the normal Cassandra image and you don't touch anything, it should work. Now, it may not work as good as you want to. It may not be tuned to the best of what you want, but it needs to work. So that's what we try to do, something that actually works. But then our ops want something very special, so they need to tinker this and there. So they had to have the opportunity to be able to do that, but it's not compulsory. I mean.
Yeah, this goes back to something I brought up a couple of weeks ago, which is the interplay between the operator and the image is very tightly coupled. And I don't think there's going to be any way to get around that. I think as part of this effort, and I understand it's a different effort than the sort of the official Apache projects or whatnot, but I don't think you're going to be able to get away around the idea of having a list of images that work with this operator or vice versa. There needs to be some sort of compatibility mapping or something going on.
As John said, that's why we explain somewhere in the documentation what an image needs to do. But it's nothing really complicated. I mean, it's
and we take the same tack at DreamWorks that I mentioned this before. We have 15 different image databases that we support, and so that spec of what an OCI image or a Docker image must support, that actually extends across all of our databases. So we have like a document that defines what a compliant image is across all databases. But yeah, I think there has to be some sort of definition of what is compliant with the operator.
And the last thing I want to say, in this file that you're actually showing here, we have examples of things that people can change the pre-run.sh file to do some specific things during the operation of the cluster. If you want to do a replace image, a replace address or something, that's what we say here. We can just change the pre-run.sh and it does a comparison with the node, the host name, and just say, for this specific node, I can change the IP or whatever needs to be done. That can be done. They just trigger a running restart and it does what it's needed. That's something that was required as well. And we needed to have that. It's not really nice to have seds and all things like that, but I mean, ops love sets. I mean, when they see it, say, "Oh, I can do things with that. That's cool."
Okay.
Right.
So,
anyway,
go ahead, John. Sorry.
Oh, no, go ahead.
Well, I mean, I notice people are dropping off, so we're losing people. So maybe this is a good time to stop. But I will schedule same time next week. Again, so we can keep going. Frank, I think another thing that would be helpful is if we engage, we have the Slack now, the Kubernetes or the Cassander Kubernetes Slack room would be a good place to have more conversation as well. But yeah, so what is the goal is, personally, I feel like what I see is we have real potential of taking everyone's ideas, potentially putting them together with all the different inputs and having something much better than any individual operator was, because everyone had different motivations, and I think that's what's important. Whether or not that it can happen, we're going to find out, but that would be great. This has been my experience in the Cassandra project that surprisingly awesome things happen when we're talking about things. That's why we have multiple compaction strategies, for instance. So sorry that we have multiple compaction strategies. John, are you in a good stopping place here?
Yeah.
Okay. All right. Well, thank you everyone for participating. I will update the mailing list. I will post this recording as well. Michael, I hope that you learned a lot about Kubernetes today.
It was helpful. Yes, indeed.
Yeah. All right. And so I will put I'll put up a meeting. I'll put it on. I'll refix the calendar. Put that up. Put it on the mailing list. But hopefully, also see you on Slack. So thanks.